Alright, good afternoon. Let's start with a new topic which is called AC power. AC power. Now there are three types of AC power. They are the true power, the reactive power, and the apparent power, PQS. P is true power or active power, and the unit is watts. And Q is the reactive power, and the unit is VAR, volt ampere reactive, right? And then S is the apparent power, and the unit is volt ampere. Okay. Now these three AC power, true power, reactive power, and apparent power form a power triangle. Now if you still remember, now if my impedance is 3 plus J4 ohm, you say that this is an inductive circuit, right? Because of the positive J. And our impedance triangle point up, that is the R, and that's the XL, and that's the Z, right? And if the impedance is Z is equal to 3 minus J4 ohm, then you say the power triangle is capacitive, and the power triangle point down, because this is your XC, and this is the R, and this is the Z, the impedance. Now similarly, our AC power also form a power triangle, which is a right angle triangle. So PQS, if it's an inductive circuit, the power triangle point up as well. It's a right angle triangle, and this is the true power, P, the unit is watts, and the JQ, that is your positive reactive power, and then the unit is VAR, right? And then the apparent power, S, or we call them the complex power, S is equal to P plus JQ, S equal to P plus JQ. So again, it is a right angle triangle, and this power triangle points up. If it's inductive circuit, the power triangle points up because this is a inductive reactive power. Whereas for a capacitive circuit, the power triangle points down. So you have P, and here's minus JQ, and this is S, right? So in other words, the thing that we want to know is that the power triangle PQS is a right angle triangle. It points up or points down. If it's an inductive circuit, the power triangle follows the impedance triangle point up. If it's capacitive circuit, the power triangle points down. So in other words, the complex power for inductive circuit is P plus JQ, right? And volt ampere. And then whereas for the capacitive circuit is P minus JQ, because it's pointing down. Now, power triangle, since it is a right angle triangle, Pythagoras theorem and trigonometry can be used, right? So this is the inductive power triangle, inductive circuit, right? And this is capacitive. So in other words, my Pythagoras theorem can be used. P squared plus Q squared is equal to S squared can be used. In other words, if I know P and know Q, I can find S by using Pythagoras theorem. Or the trigonometry that P is equal to S cosine theta, Q equal to S sine theta can also be used. Can you remember? This is the hypotenuse, this is the adjacent, this is the opposite. So P is equal to S cosine theta, Q is equal to S sine theta. Because cosine theta is equal to P divided by S, sine theta is equal to Q divided by S. So knowing any two parameters of a power triangle, you can find the rest, right? Let us go through a simple example. Right, if I were to tell you that in an AC system, the true power is equal to 3 watts, and the reactive power is equal to 3 VAR, 4 VAR. Right? Then you're asked to find the apparent power. Okay? So you know that apparent power is equal to, or the complex power is equal to P plus JQ, because you are told that this is the inductive circuit. Inductive circuit. Right? So it's equal to P plus JQ, so it's equal to 3 plus J4 VA. Right? Or you express it in polar form, it will be 53.13 degree VA. Right? So that is called the complex power. Complex power means it's a complex number. Right? If I were to say the apparent power, then the apparent power is just referring to the magnitude. So it's 5 VAR. Right? And the complex power, you have to express it in terms of complex number, is 3 plus J4 VA, right? Or 553.13 degree VA. Got it? So that's the introduction of the AC power. Alright, so that's the first point. Now we move on to the second point. Second point is talking about if I have an AC system, for example, I have here, and I have 3 loads. Right? This is load 1, load 2, and this is load 3. Right? And I have P1, I have Q1, and I tell you that this is an inductive circuit. Right? And load 2, it has P2, it has Q2, and I'm telling you that this is capacitive circuit, capacitive load. And load 3, I have P3 and Q3, and it's an inductive load. So you see in my AC system here, I have 3 loads, load 1, load 2, and load 3. Now I'm asking you, find me the total true power, total reactive power, and total apparent power. Okay, so what do you do? Now the way to do it is, because power triangle either points up or points down, so you need to know which one points up, which one's point down, so you can add accordingly. So for this one, this is an inductive circuit, so my power triangle points up. So this P1, this Q1, and this is S1. And the second load is a capacitive circuit, so my power triangle points down. So this P2 is minus Q2, and this is S2. Right angle triangle. And the third load is pointing up again because it's inductive, so it's P3, Q3, and S3. So when you add up the power, total power, they are all horizontal, P1, P2, and P3. So you just add it up. So P1 is equal to P1 plus P2 plus P3. Right? And for the Q, this is a positive Q, this is a negative Q, and this is a positive Q. So it's therefore Q1 minus Q2 plus Q3. Okay? And the apparent power or the complex power will be PT plus JQT. Okay? And depends on what is your answer lah. If your answer is positive J, then it will be P plus JQ. If it's a negative answer, then it becomes P minus JQ. Right? So that is the apparent power or complex power. So when you are asked to sum up the total power, this approach will be very helpful. Ask yourself, for my individual load, my power triangle points up or points down. Then you can add and you can subtract easily. Okay? Now, I would like to say that some students, they will say, they will just say ST equal to S1 plus S2 plus S3. If you were to just add like that, it is wrong, because if you don't express them in complex number and it's just the value, the hypotenuse value, you just add them, it will be wrong, because you cannot add lines of different angles together in this manner. You have to resolve them into total true power, total reactive power, and then express it as a complex number or Pythagoras theorem. Okay, so that's point number 2. Point number 3. Before I move on to point number 3, maybe we'll just ask ourselves about this pointing up and pointing down. Now, in your tutorial question, many a times you are not told whether it's capacitive or inductive directly, but you are told in an indirect manner. For example, you are given that this is a P1, Q1, you are told the value, and then you are told that the power factor is equal to 0.8 lagging. Okay, then you are told that this is S2, and then the power factor is equal to 0.9 leading. Alright, and then this is S3, P3, Q3, and you are told that this is an inductive circuit. So if you are given this information, the power factor is lagging. So power factor is lagging is an inductive circuit. So the power triangle is point up, P1, Q1, right? S1. And point 8 cosine inverse will give you this angle. So if you know the angle, you know Q1, you know P1, you can find S1 easily. Yeah? And the second power triangle is leading, so it's capacitive circuit, so the power triangle should point down. Right? And this will be your P2, Q2, and S2. Alright? And again, because you are given the angle, cosine inverse 0.9 will give you this angle, and you know S2, you should be able to find P2 and Q2 quite easily. And inductive circuit, power triangle is point up, so this will be P3, Q3, and S3. Got it? So even though information is not given to you in a very directly manner, but when you see the power factors lagging or leading, you should know whether it's inductive or capacitive, and draw this small power triangle pointing up and down accordingly, and then you can sum it up nicely. Okay? Alright, point number 3. Point number 3 is that there are other ways of finding power. For example, if I have an inductive circuit here, this is 3 ohm and this is J4 ohm, and the current is equal to 1.6 20 ampere. Right? Now, if you are having this kind of information, P, because true power happens in the resistor, active power happens in the resistor. So P can be I square R formula, right? And Q happens in the reactance, so it's I square X. Okay, and apparent power is I square Z. Apparent power happens in the overall impedance. So in this example here, all your I, when you use power formula, it must be the RMS value. So I is the RMS current is 1.6, so it's 1.6 square times 3 watt, right? And Q is equal to I square X, so you also need the RMS value, so it's 1.6 square times 4 VAR. And in terms of the apparent power is I square Z, so it's 1.6 square. And what's the impedance? Impedance 3 plus J4, which is 553.13 degree. Right? So it's 5 VA. Get it? So the power formula that you have learned before, P equal to I square R, can be used. Okay? True power, reactive power, apparent power. Likewise, you can also use V square over R formula if the circuit is parallel. Alright, say for example this is 10 0° volts, right? And then this is a resistor 3 ohms, and this is the inductance 8 ohm, for example. Now again, you can use the formula P equal to V square over R, because this is the parallel circuit. You know the V here, you also know the V here. It's parallel, 10 volt, 10 volt, 10 volt. So you can say 10 square divided by 3 watt. Right? And the Q is equal to V square over X, so it's equal to 10 square divided by 8 VAR. Got it? Now how do you find the S? Now to find the S is to find the impedance of both, right? It's a bit troublesome. So since you know PQ, you can find the S easily, right? So this P minus JQ, because it's a capacitive circuit. Capacitive circuit is pointing down, remember? So P minus JQ, or you want to use Pythagoras theorem, that will be P squared plus Q squared. So that is power formula. You can use P equal to I squared R formula or V squared R formula, provided that you know the values of the I and the V in the circuit. Now another way of finding power is using trigonometry. So if I have a circuit like that, and I have this load, this 3 ohm, and this is J4 ohm, for example, and then okay, so this is R and this is JX, and then I have the voltage here is 10, 0 degree, and the current here, the current in this circuit is 6, 20 degree ampere. Alright? So we can use P is equal to, if you remember just now we say about the trigonometry, this P, Q and this S, right? P equal to S cosine theta. Yes? And Q is equal to S sine theta. S sine theta. Right? So P is equal to S cosine theta. And what is S? S is I times V. Power formula, remember? I times V cosine theta. P equal to IV cosine theta. Okay? The value of the I is the RMS iron, RMS 6. The RMS voltage here is 10. Cosine angle between the voltage and the current is 0 and 20, so it's 20 degrees. So it's watts. IV cosine theta. The angle here is the theta V minus the theta I. So it's 0 minus 20 degree, that's minus 20 degree. Right? Cosine minus 20 degree is the same as cosine 20 degree. Okay, so whether you say cosine minus 20 degree or cosine 20 degree is the same thing. Then Q is equal to S sine theta. Can you still recall that? Opposite divided hypotenuse. So Q is therefore equal to IV sine theta. So it's 6 times 10 sine minus 20 degree VAR. Okay? And how about S? S is equal to V times I, or I times V, right? So therefore it's equal to 6 times 10 VA. Okay? Alright, I will pause here for a while and let's go through a simple revision of this before we carry on with the further things about the AC power. We say about there are 3 types of AC power: P, Q, and S. True power, reactive power, apparent power, or complex power. And these 3 powers form a right angle triangle: P, Q, and S. If the power triangle points up, because this is the inductive circuit, if the power triangle points down, positive JQ and minus JQ, then this is a capacitive circuit. We also say that because it's a right angle triangle, so Pythagoras theorem can be used, right? Or the trigonometry can be used: P equal to S cosine theta, Q equal to S sine theta, right? Then the second point, to sum up the total power, or the total reactive power and the total apparent power, you actually need to know the individual power triangle. Are they all pointing up? If some point up, some point down, do you know how to sum it up? Then the third one, to find power, there are various formula to use, right? P, you can use I square R, you can use V square over R, right? Or you can say it's equal to IV cosine theta. Now make sure that when you use formula, they are all in the power formula. All the values are in RMS value. Okay, we'll take a break.